Hey future coders, welcome back to Programming with Swift Playgrounds. Now, this is a special module here today because if we look at the chapters, we've finished the commands, functions, for loops, conditional code, logical operators, and while loops. So this is the last chapter in this particular Learn to Code 1 series. Now let's take a closer look at algorithms. What are they? Well, an algorithm is just a fancy name for a set of rules and instructions that you can use to solve a problem. And if you want to sound smart to your friends or your parents, try using the word algorithm in your sentence. For example, if you're navigating an app, it will use an algorithm to figure out the fastest way to get where you want to go. So, to avoid traffic, your app will go and compare the distance and average speed from where you are to where you want to go. It'll also compare the current traffic conditions and then select the route with the shortest travel time. Now, if you want to know how it knows the traffic conditions, what Google does is it monitors your cell phone and it can tell which road is busy by how many cell phones there are in a particular area. So now suppose you need to direct a car in a car park to find a space. What instructions or rules can you use to move the car around the building? You can say, while there isn't a parking space, keep on driving forward. But the algorithm doesn't tell the car to turn at the end of the building. So what you can say is that if you're blocked on the right, keep driving forward. Otherwise, you can turn right. So the car will keep on checking, is the right hand side blocked? Yes, move forward until it's free and then you can turn right. Here we go. It's not blocked and then it can turn right. But guess what? We keep on turning right, so we need to tweak the algorithm. Can you guess what we need to do? Well, after turning right, we have to drive forward. And then we can find a car park. A lot of the code you've written so far has actually been instructions to solve problems, so you've actually been writing algorithms this whole time. We'll use these skills and more to continue to master this last section. So let's start coding. This challenge here is called the right-hand rule, where we're going to use a right-hand algorithm to navigate around the wall. Basically, if you look at the puzzle here, we will move around the wall as long as our right hand can touch the wall. So you can see we've been given some code already where let's see how it works. Down below we say, while we're not on a gym, go to the function called navigate around the wall. What this does is it says if we're blocked on the right, in other words, if there's a wall, keep moving forward. Otherwise, turn right and then move forward. So let's step through this code slowly to see how it works first. The code says, are we on a gym? No, let's navigate around the wall. And this is our loop. Are we blocked on the right? Yes, we are. Move straight forward. Repeat this until we get to the very end. Now, are we blocked on the right? We're not. So let's turn right and move forward. So we're blocked on the right, so move forward. Now we're not blocked, so we want to turn right and then move forward, going down this channel here towards the gym. Now we continue to move forward, and then in our while loop we say, well, actually we're on a gym, so what should we do? Well, the best thing to do is to go and collect the gem. So let's step through this code a little quicker this time. Now after we've collected the gem, you'll notice that nothing happens. That is because the code has stopped. Now we need to keep the code going until we reach the end. Do you know what's at the end? Well, there's a closed switch. So what we need to do is say while we are not on a closed switch. Not is closed switch. Like so. If we're not there, then continue to walk around. Like so. And what happens if we're on a closed switch? Well, let's toggle the switch. Now let's see what happens here. Let's go ahead and run the code. And I'll run this a little faster before stepping through the code here. We're going to move forward. Down here, collect the gem. We're not on a closed switch. We want to navigate. We're blocked on the right, so we move forward, but we cannot move forward. We'll fall off the ledge. So we've got another bug in our code. Because we are blocked on the right, which means we have to move forward, but we can't. So let's stop it here. And the trick here is to, after we've collected the gem, we need to turn left 2 times. Because what this means is that when Byte turns left 2 times and is facing forward again, Byte will be blocked on the right and can continue to move forward. Don't believe me? Let's check this out. Here we go. Step through the code. Navigate around the wall. Move forward. Are we on a gem? Yes. Let's collect the gem. Turn left. Turn left. And now we can continue to navigate around the wall. Excellent work. Let's move this a little faster. I'm going to slow it down here because we're going to continue to move forward. Are we on a gem? No. And now we're going to move forward and we're on a closed switch. But guess what? We're still inside the nested loop. So we're continuing to want to move forward because we're not on a gem and there are no gems. So there's another bug in the code. So let's stop here and think, how can we solve this problem? Well, we know we have to navigate around a wall, but the condition of while on a gem is not quite correct. Because if I remove the while condition here, let's see if this works. So we're not on a closed switch. So let's continue to navigate. So look at that. We're collecting a gem every single time. But as you know, we should only collect a gem if we're on a gem. So if is on gem, let's collect the gem. And then we can turn left 2 times. So we've got our if condition here. So let's try and step through the code now. Let me speed this up a little quicker. And let's check this. Are we on a gem? No. Let's navigate around the wall like usual. Now, are we on a gem? Yes. Collect the gem, turn left 2 times, and then continue to navigate around the wall. Now, let's run this a little quicker. And then continue to navigate. Are we on a gem? Yes. Let's slow this down. Are we on a gem? No. Navigate. Continue to navigate around the wall. Let's turn right. And let's go down the last alleyway and see what happens. Now, are we on a gem? No. Are we on a closed switch? Yes. So let's toggle the switch and then we complete the puzzle. Great work, future coders. So by writing a set of instructions to follow the rules, we've created this algorithm. And guess what? We'll be using this in the next challenges to come. So let's jump on now to the next page. This challenge here is called adjusting your algorithm. Now, if we take a closer look at this particular puzzle here, you'll see that it's actually very similar to the one we had before. However, we've got some more blocks around the wall to prevent the right-hand rule from working. Because in some situations, we're blocked not only on the right, but also in front of us, such as down here and up here. So we need to modify the code to handle this situation. Now, we've got some code given to us down here. So let's first of all run this to see what happens. So the end condition is on a closed switch, which is fine. Now we're going to navigate around the wall just like how we did before. We're blocked on the right, so let's move forward. Are we on a gem? No. Let's move forward because we're still blocked on the right. Now we're not blocked on the right, so let's turn right and move forward. So this is working well. So let's speed this up. Haha, look what's happened here. We're blocked on the right and also in front. So let's stop the code and add another condition. Why don't we say if we're blocked on the right and we're blocked in the front, turn left? Because the same situation happens here, 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 and all these corners. So let's go else if is blocked and is blocked right. What do we want to do? Let's try turning left, like so. Let's give this a go. Okay, so we're still running into a problem here because we're blocked on the right and we still want to keep moving forward. What it means is that we've got the order wrong. So what if we take this condition, let's copy it, and let's paste it at the top and change this to turn left. So we're just going to change the order here. Like so. Now let's run through this to test it out. Here we go. Is this working? We're going to navigate around the wall. We're blocked on the right, so let's move forward. Are we blocked in front of us? No, so let's turn right and move forward and continue. Looking good so far. Going into the corner here, we're going to collect the gem, turn left 2 times, and then we're blocked on the right, so move forward. Now check this out. We're blocked on the right and in front, so let's turn left. This looks really good. Let's continue to speed this up a bit. And look at that, we're moving towards the end and we toggle the switch and we've solved the puzzle. Great work, future coders. Basically, we had to make one minor change. So that was if we're blocked on the right and in front of us, we want to turn left. But we also had to make sure the order was correct because the minute that we were blocked on both of these conditions, we turned left first before just being blocked on the right. So let's now move on to the next challenge. This challenge here is called Conquering a Maze, and again we're going to use the right hand rule to navigate through the maze. The first thing we want to do is look at the maze carefully and understand the pattern. What is it that we want to do? Well, you can see we want to collect the gem, so this is the final goal. Next, how do we get there? Well, we can go up here and then around this way, up the stairs, and then up these stairs, then back down here, down the stairs to the gem. So let's think about the right hand rule. If we're blocked on the right hand side, keep going forward like so. Here, if we're blocked on the front and on the right, turn left. And then if we're not blocked, we want to turn right and move forward, just like the previous puzzles. So let's use that as a starting point. The best way to start, as always, is to look at our end condition, and that's a gem. So what we want to do is say, while we are not on a gem, we want to move forward, like so. Now, see how this works. We're not on a gem, move forward, and move forward. But guess what? We've got nothing to tell Byte to turn the corner. So let's stop here and say, if is blocked on the right, move forward. But remember that when we reach this condition here, we are blocked on the right and in front of us. So else, if blocked and is blocked on the right, we want to turn left. Else, if we're not blocked on the right, then we want to turn right and move forward, like so. Now you might be thinking, does the order matter? Because we switched them around in the last puzzle. Well, sometimes it does and sometimes it doesn't, but let's find out. Let's go ahead and step through the code. Are we blocked on the right? Yes, let's move forward. Are we on a gem? No, so let's continue checking our if statement. Here we go. We're blocked on the right and we want to continue to move forward, but you'll notice that it never reaches the second condition. So to answer your question, we do have to flip them around. So let's say is blocked on the right and in front of us. Let's turn left. If we're blocked on the right only, then let's go and move forward, like so. And let's retest by stepping through the code. Oops, I've got a double bracket here. So let's go and fix that. And now we can step through the code. So we're still blocked on the right, move forward. So let's see what happens here. After we reach the end, we're going to be blocked. We turn left. And we move forward. We're not blocked anywhere, so we turn right and move forward. Oops. Oh, yes it is. There was a glitch. So you can see that Byte moved forward, but after the glitch fixed, we're on the right track. So now we turn left. And let's try and speed this up a little bit and see if it works. Looking good so far. Oh, look at this. Byte goes to the end and then comes back and then reaches the gem. Great work. Now, the final piece is that when we're on a gem, we want to collect it. There we go. So let's run this faster and collect the gem. Now you might be thinking, couldn't Byte turn down here, these stairs, and take a shortcut? Well, yes, Byte could, if we change the code as well. But here, we're trying to keep to the right hand rule. So the right hand follows down here because we're blocked all the way, and then we come back here, and then the right hand side isn't blocked. Hence, byte goes down. So if you reached this stage, future coders, you're doing really well. Let's now move on to the next challenge. Okay, this challenge here is called Which Way to Turn. Now, you need to write your own algorithm to solve the maze. So we've tweaked several algorithms so far. So now we have to practice what we've learned and write the code from scratch. As always, the first thing to do is to understand what we need to do. So you can see the end goal is to go ahead and collect the gem here. But on the way, we've got 6 switches to turn on. So the first thing I like to do is let's ignore the switches. Don't worry about that. Let's see if we can find some patterns first. Using the right hand rule that we've learned, you can see that we can move forward to this switch and then we can go down the stairs. And if we're blocked in front of us, we can then turn left. If we're blocked in front of us, turn left. And then here we turn right. If we're blocked in front, turn left. Blocked in front, turn left up to the gem. So there are a few patterns that I mentioned here. Do you know how we can start off? Well, as always, we want to look for the end condition. So that's the on gem here. So we want to say while we're not on a gem, keep moving. Is not on gem. And then, again, if I move forward, then that's okay. But we want to say if is blocked on the right, move forward like that. Just like how we've done it before. And then we want to say else. So the blocked right will move us forward to the first switch. And then we want to turn down the stairs. So let's go else, turn right, and move forward. Just like how we did in the previous puzzles. The trick is that when we come down to this square here, we're going to be blocked in front of us. So what we can do is say, well, let's turn left. So if I say if is blocked, how about turning left? Let's give this a go first and see if it works. Oops, there's an error here. I need an else if, and now I can step through the code. Here we are, we're blocked on the right, so let's move forward. Now we're not blocked at all, so let's turn right and move forward. We're still blocked on the right, so we move forward. We're going to be blocked in front of us, so let's turn left. Now let's continue to move forward, so far so good. Until we're blocked in front of us again, where we want to turn left. Whoops, look at this. In this situation, we're blocked in front of us and on the right. So let's stop this and let's see what's happening. In this situation here, we've got 2 conditions, blocked in front and blocked on the right, but we've got nothing to tell byte what to do in that situation. So why don't we again just play around with the order and move this if up above. So let's go if we're blocked. We want to turn left. Else if we're blocked on the right, we want to do what? You got it. Move forward. So just by changing the order allows us to solve this particular problem. Again, let's step through the code. Here we go. We're blocked, so let's turn left. Are we blocked? Well, we are blocked on the right, so we want to move forward. Let's again speed this up. And look at this. We're going through the maze, making all the right turns, and reaching the end. Look at that. Now that we have completed this part, you can probably guess the last piece of the puzzle will be to what? If you said collect the gem, that is correct. And we also need to toggle the switch. So we can test every square that we're on and say if is on close switch, toggle the switch, like so. The other way to do it is to recognize that the switches are at the intersections or whenever you're turning. So we could put this condition inside these turning instructions instead of testing for every single square. And both solutions will give you the right answer, but let's try this one first and run through the code. Look at that. Here we go, the last part. And we've solved this puzzle. That is super work, future coders. We're building on our skills of moving around a maze using the right hand rule and turning when we have to. Let's now move on to the next puzzle. This puzzle here is called roll right, roll left. And now this puzzle is actually the last one in this chapter, so it's going to be quite challenging. We're going to have to use all our skills to try to pass this puzzle. Now the first thing to do, as always, you should be getting used to this, is to look for patterns. We can click on the hint and you'll see, again, you have to look for patterns. Notice that whenever gems are present, the path moves to the right. Whenever switches are present, the path moves to the left. So there's a little hint for you there. What I like to do is I want to move into my first starting position. So I want to move forward and then I want to turn right. Like so. Let's run the code. There we go. That's the first step. And then the second step is to recognize what is the end condition. How can we make byte move and stop at the very end? Well, you should be able to see that there is an on open switch. All of these are closed, but the last one is on open. So if I can say while not is on open switch, then let's do a whole bunch of things. So if I'm not on the open switch, let's do what? Well, we can move forward. Using the right hand rule, we used to say, well, if the right hand side was blocked, just keep moving forward. But notice here that the left is blocked, 2 tiles, and then here the right is blocked for the remaining tiles. And similar on this side here, where the right side will be blocked, and then this left side is now blocked coming down here. And then all on this side, the left is blocked and then the right is blocked. So it changes from between left to right. So because of this, I can say if is blocked right, or remember our logical operators, is blocked left, move forward. Let's see if this works. Step through the code. Look at that. We're able to move forward to the very end. That is great. Don't worry so much about collecting the gems or the switches yet, because we have to make our way through the puzzle correctly. Now we need a turning condition. So let's stop the code and say else if, now if we're blocked from the front, so is blocked, how about turning left? Now let's see if this works. So let's step through the code. Oh, so here we're actually still blocked on the right hand side, hence this code is being executed before this code here. So again, we want to go ahead and change the order. So let's go and stop the code and say, let's copy this. If we're blocked, we want to do that, else, and then delete the bottom code. So we've just flipped the order around And let's give this another test. There we go. So we were able to turn the corner. What's going to happen here though? Oh, we're turning left and going backwards. That's because we're blocked in the front. So we're turning left, but we actually want to turn right. So we're going to end up in this infinite loop. So that's a problem we need to solve. So let's stop there. And we need to find a condition for us to turn right. Can you guess what that condition is? Well, why don't we say, if we're blocked on the left and in front of us, turn right. So let's go, else if we are blocked and is blocked on the left, then let's turn right, like so. Let's now run the code again and do a quick check. Well, it didn't work there. And can you guess why? I betcha it's because of the order. Let's just double check the order here. Now, we're going to be blocked first. Here, we're going to be blocked, so we're turning left, because we want this one to execute first. So again, let's stop this and change the order around. Now let's test this again. Look at that. So far, so good. Okay, that is super work. So we've got the algorithm to move throughout the entire maze. All we have to do now is start to collect the gem. So let's say if is on gem, collect it, like so. And then we can also say that if we're on a closed switch, we want to toggle it, like so. So let's give this a test and see if it works. So we're going forward. We're going to turn left now. We're going to go on a switch, and then we turn it on, and then we stop. That's strange. Let's try that again and step through the code. So we're not on a gem, we're not on a closed switch. We're blocked on the right, so we move forward. We're not on a closed switch. We're blocked in front of us, we turn left. We're not on an open switch. Again, we're blocked on the right, so we move forward. We're not on a gem. We are on a closed switch, so we toggle it. And then we go ahead and turn left. And then the code stops because we're already on an open switch. That's interesting. So the whole code is based upon if we are not on an open switch, because if we are, then we stop. So that's why the code has stopped. So what we need to do here is after we toggle the switch, we need to move byte forward one and take byte off the open switch. Let's try this. I'm going to slow it down. We'll step through the code here. Now we're not on a gem, we're not on a closed switch. We are blocked on the right, so let's move forward. Now we are on the closed switch, so let's toggle it and move forward. Whoops, we didn't want to move forward actually. We wanted to turn left and then move forward. So let me change this and then get back up to this position. Here we go. Let's move forward again. Now we're on a closed switch, so let's toggle it, turn left, and get off it. Perfect. Now what's going to happen? Well, we're blocked, so we have to move forward. We've actually missed this switch. That's not great. And if I go ahead and run through the entire code, you'll see we're going to miss the second switch. Look at that. So let's stop this, go back to the drawing board and see, well, we actually have to move forward, but the condition down below is going to be true So we actually move forward 2 times. What can we do? Well, how about we take the condition if we're on a closed switch and put it, let's cut this and put it to the end of the code. So after we've moved forward, we can then do a test instead of testing beforehand. Let's go ahead and run this again. And we'll step through the code when we get closer. So we're not on a gem and we are blocked, so let's turn left. We're not on a closed switch. We're actually blocked on the right, so we move forward. We are on a switch, toggle it, turn left, move forward. Now what are we going to do? Well, we're actually stuck in the same situation. One thing to note here is that notice the pattern that we've got 2 switches in a row. So what we could do is move forward. We could toggle the switch again and then move forward to get off the toggled switch. Let's try this. Now we're going to move forward again. Are we on a closed switch? Yes. Toggle, turn left, move forward, toggle, and then get off the switch. This allows our code to continue, and then we keep walking through the puzzle. Let me speed it up a bit, and we'll see if this works. So far, so good. Look at that, future coders. We managed to solve the last puzzle of this particular chapter and of the Learn to Code program as well. Now, there will be other solutions as well, but this is one possible solution. It's quite neat, it's short, and hopefully it's easy to understand as well. So you've just completed Learn to Code 1, and you're now a coding master, believe it or not. You've come a very long way. So give yourself a pat on the back, take a break, because coming up next is we've got the Learn to Code 2 section to take your skills to the next level. I'll catch you then.